4.6 billion years ago, Earth emerged in a chaotic solar system. Serendipitously positioned within the habitable zone, it enjoyed optimal sunlight and temperature. During its formative stages, Earth experienced impacts from comets and asteroids, enriching the planet with abundant liquid water. These seemingly incredible coincidences indeed unfolded as reality. Hundreds of millions of years later, the first single-celled life appeared in Earth's oceans. Over the course of billions of years of evolution, life gradually spread from the oceans to the land. Until about 200 million years ago, a powerful class of reptiles stepped onto the Earth's stage of life, becoming the dominant force on the planet. We call them dinosaurs. There were various species of dinosaurs, ranging in size from 10 centimeters to 30 meters and weighing tens of tons. If humans represent the pinnacle of intelligence in Earth's life, then dinosaurs represent strength. Especially the Tyrannosaurus rex of the late Cretaceous period, they were massive, with well-developed facial muscles, and their bite force could reach around 120,000 newtons, making them the strongest biting animals in the world. At that time, there was no animal that could rival the Tyrannosaurus rex. However, no matter how powerful an animal is, ultimately it depends on the Earth. If there were turmoil on Earth, even the dinosaurs were just flesh on the chopping block. 65 million years ago, an asteroid with a diameter of about 10 kilometers collided with the Yucatan Peninsula in present-day Mexico. The energy released from this asteroid impact was equivalent to 3 billion times that of the Hiroshima atomic bomb, resulting in the extinction of 70% of species at the time, and bringing the era of dinosaurs to an end. The asteroid impact theory is the most mainstream explanation for the extinction of dinosaurs. We cannot witness what exactly happened at that time, so we can only search for a large amount of evidence to support this hypothesis. The huge impact crater in the Yucatan Peninsula and the sudden climate change at that time have provided support for this hypothesis. Recently, Australian scientists studying lunar craters have also discovered some clues. Scientists from Curtin University's Space Science and Technology Centre in Australia have conducted research on samples brought back by the Change 5 mission. Some microscopic glass beads caught their attention. These tiny glass beads were not naturally formed on the moon but were formed under high temperature and pressure during meteorite impacts. In other words, by assessing the age of these glass beads and combining data modeling with geological surveys, a timeline of lunar impacts can be established. Lunar impacts and the extinction of Earth's biota are somewhat related. Meteorite impacts are often not isolated events. Earth's disasters may accompany a series of small impacts on the moon and be influenced by meteorite fragments. The age of some glass beads indicates that they were formed approximately 66 million years ago, coinciding with the time of the asteroid impact on Earth. According to scientists' calculations, this 10-kilometer asteroid was hurtling toward Earth at a speed of 12 miles per second, ultimately leaving a massive impact crater in North America. Scientists believe that it wasn't just this one asteroid that collided with Earth at that time. Other smaller asteroids also followed suit, collectively bringing about Earth's catastrophe. Dinosaurs did not become completely extinct at the moment of impact. Only the biota within approximately 1,000 kilometers of the impact site turned to ashes. The real terror lies not only in the shockwave brought about by the asteroid's impact but also in the series of chain reactions that followed. The enormous impact triggered major earthquakes and super tsunamis. Scientists have found sand from the ocean in terrestrial layers at that time and plant debris and rocks from the land in marine layers. The tremendous impact shattered the Earth's surface into fragments, which were then propelled into the atmosphere at high speed. Upon re-entry, they heated up due to friction with the atmosphere, becoming fireballs before crashing back to the ground. This meteorite shower caused extensive wildfires on Earth, resulting in devastating destruction of animal habitats. And this was just the beginning. The damage from the meteorite shower was only regional, while the dust cloud covering the sky was the final fatal blow. The dust cloud spread across the world due to atmospheric movements, triggering global climate change. The dust obscured the sunlight, significantly reducing the heat reaching the Earth's surface, ushering in darkness and cold. Unlike humans, who can take a plunge into cold lake waters during winter swimming because humans are warm-blooded animals, with their internal temperature remaining constant regardless of external conditions, dinosaurs, being cold-blooded, would experience the same external temperature internally. Thus, the onset of cold was fatal for dinosaurs. On the other hand, the reduced sunlight weakened photosynthesis in plants, leading to mass plant deaths. Subsequently, herbivorous dinosaurs were the first to go extinct, followed closely by carnivorous dinosaurs, marking the end of the dinosaur-dominated era. Meanwhile, mammals seized the opportunity. At that time, mammals were small in size, had smaller appetites, and were warm-blooded. They survived the mass extinction and thrived as the environment gradually improved. With the environment stabilizing, Mammals underwent rapid development, eventually leading to the emergence of humans and the current human civilization. Over the past few billion years, Earth has experienced 5 mass extinctions, each reshaping the ecosystem dramatically. These events saw the extinction of some species and the rise of others. As the only highly intelligent life form on Earth, humans should learn from the past to avoid becoming casualties in the next reshuffle of life on the planet.